Good morning, good afternoon, and welcome to Smartlogic's webinar, Fair Data with Knowledge Graphs and AI. My name is Ann Kelly, and I'll be your host today. And our speakers today are Frederic Landqvist, who is a senior information architect with our partner Findwise, and Jim Morris, who's a senior information scientist here at Smartlogic. And many of you know Jim, he does a lot of webinars with us, and we've done webinars with Frederic in the past as well. A few housekeeping items before we get started with the webinar. This webinar is in broadcast mode and all participants are muted. If you have questions, please put them in the GoToWebinar panel that you should see on the right-hand side of your screen, and we'll answer them as many of them as we can in the Q&A session. We have about 45 minutes worth of content today, and then we'll open it up for questions. And finally, this broadcast is being recorded and replay information will be sent to all registrants following the broadcast. And with that, I'm going to turn it over to Frederic.
Good morning and good afternoon, everybody. I'm happy to have you attending to our session today. I'm very pleased to have my So there you go. Good morning and good afternoon. I'm very pleased to have you all here, and especially I'm happy to have my good old friend Jim with me on the call. We have known each other for 18 years, I realized, and spent 8 years in the knowledge management and information management trenches, working with information and data governance to enable global capabilities, search, taxonomies, and enterprise metadata. We both share a passion for information architecture. That means, making sense of data, but arrive to the arena from two different perspectives. Jim, being an information and library science expert, and me being a nerd from the system analytics and working with data from a modeling perspective, and who likes to tinker with technology. The idea for today is that we will try to share our experiences today and walk you through the concepts of fair data principles and lean into the knowledge graph discussions and what we can bring forward with possible uses of AI. So without further ado, I hope to give you a good journey. So, data-driven organizations, well, they all are looking for the golden nuggets, well, as these guys here, trying to be able to find and access and make sense of those data assets that you have and make reuse of them with sound and sustainable data governance principles enacted, having the human in the loop. We can have new ways of working, and smart means will hopefully, actually automate, enrich, and connect our enterprise data landscape. So we get trusted quality data assets using enterprise knowledge graphs to bridge to the business context. But what about FAIR? Well, it all started way back approximately a decade ago in a collaborative project was called Open Fact within the life sciences, where many pharma actors were working together to speak about scholarly sharing data assets. And the term was fair data was coined in a workshop in Lawrence in Netherlands in 2014. To a large extent, it reflects commonsensical guidelines to data and information management, as findable, where you use unique identifiers and rich metadata, accessible, use access standards, protocols, and authentication, and as always, have your metadata handy, interoperable, vocabularies that are true and fair with rich metadata, and reusable, metadata that is multifaceted, usage licenses and provenance upfront, so you can trust your data and be assured who is responsible for provisioning of this data, and lean upon those community standards to do these things. The funny thing is that, well, the semantic web as it was coined by Tim Berners-Lee, had the ambition to connect internet, and that gave a way for linked data or open data standards, as in this case the 5-star ladder, which to some extent actually reflects the notion of what we are speaking about today with fair data. It was actually 20 years ago, in May 2001, that Sir Tim Berners-Lee wrote his essay in Scientific America, where he, in his narrative in that essay, describes smart, that is, assistants or helpers, who infer on public semantic data assets to guide humans in everyday problem solving. So, what about knowledge graphs? Well, actually, almost a decade ago, our good friends from Google launched its Google Knowledge Graph. The thing that we see on our everyday use when we search, we get this knowledge pane on the right-hand side of the screen, describing things and facts and figures. And search technologies have been frontrunners in the emerging technologies dealing with heterogeneous and complex data assets with applied means to collect, process, refine, enrich, and disseminate, to do data transformation, cleaning, automation, machine learning, and obviously natural language processing, to decipher the unstructured masses of data. Also adding symbolic representation as we know it with knowledge graphs, which will improve precision and recall. The term knowledge graphs have been popularized by the semantic technologies behind the scene. Well, the graph theories is by no ways new. The notion of knowledge representation with models or ontologies has been a tool to decipher and organize world entities since way back, as Aristotle's ontology of change. In the 70s and the 80s, the AI domain leaned upon semantics as the Psych project from 1984, trying to build a knowledge base. With the advent of semantic web came some core building blocks and data standardizations from W3C as RDF, SCAS, OWL, Shackle, and more. But the essence of all this, that is a simple notion of subject, predicate, and object from the RDF, which gave way to build a knowledge known techniques as we have been working with systems using entity relationship diagrams and conceptual domain models. In all this, bridging machine readable and human aspects, where the knowledge representation in models, knowledge organizing systems as vocabularies, add meaning to the concepts and data. Many things in the world are very easy to represent as a graph with nodes and edges, and all platform vendors, software houses, or services do today have means to deal with knowledge graph. Hence, the long-haul journey since 20 years back with the semantic web have become core technology everywhere. Algorithms and graphs, query languages also evolve as Sparkle, GraphQL, and more, underpinning rich and smart data integration in any enterprise or organization. But there is a cornucopia of open standards, vocabularies, and knowledge models ready to be reused and interlinked. Well, as it mentioned, the linked open vocabularies. Within many domains and business sectors, there's been really good curation of resources that has been collaboratively been developed and shared, kind of standing on the shoulders of giants. As an example, in healthcare, you have HL7 and FHIR to do health data exchange, or from the European Union, you have Eurovoc, which is a multilingual thesauri that covers quite many topics. But also we have really big RDF-based data sets as Wikidata, DBpedia, Microsoft's academic knowledge graph, and many more. What it all boils down to is that most concepts known to man have some fact and knowledge representation that could and should be interlinked with the enterprise data assets to enrich the metadata. No time to waste and reinvent the wheel, as the saying goes. But in all vocabulary management or information management projects that I have been surviving, if you will, one needs to set the focus on the use cases, the user journeys, and the expected utility of the data asset that you want to collect. Well, basically, hence, it's key to be able to navigate in the masses of standards. There are many, and the models and the overlapping ontologies and vocabularies to tailor feasible and useful set of vocabularies to be reused in that specific context you're focusing on. That also means that when it comes down to data governance, it entails organizing principles to support the life cycle of the data from inception to its final destination, with clear and useful responsibility shared amongst all the actors, kind of a participatory design to data. Everybody has to know and own and have responsibilities about the data that you create and cultivate. But to curate and manage and refine knowledge models as taxonomies, thesaurus, vocabularies is by all means a human endeavor. But new emerging technologies come handy, making the knowledge engineering practice a little bit more smooth, seamless, efficient, and effective. I mean, we have all struggled with spreadsheets from hell, collecting all kinds of terminologies across the business to make some sense of that. And well, I still struggle with spreadsheets, and Excel is one of my tools that I still everyday use. But that still said, we can, by those new means, use those to automate the process using different machine learning algorithms to decipher the data that we get hold of and augment the content, meaning actually interlink those assets with really rich metadata that is interlinked and useful. So I thought of, well, moving into kind of a societal contemporary data challenges with, well, basically bad data or bad data practices is all over the place. And we can see a humongous increase of volume, shape, and form and speed of change to those data assets that are just, flowing out. So I wanted to explore those venues of pain, if you will. I thought of using a thematic narrative of outbreak with the pathogen, coronavirus or COVID-19, and also some things about smart infrastructures, and lastly, a little bit about environmental and sustainability means. So with that said, data provision within health and well-being domain is by all means a complex setting, bridging between patients and citizen-centric views and professions, as the notion of personalized medicine, deep medicine, and the connected patient. The health and life science realm have since way back been very active and diligent in creating knowledge models to be shared with the different practices and professions to solve the issues with treatments and secure healthcare provisioning across the board, leaning upon standard classification schemes like ICD-11 or MESH, SNOMED CD, LOINC, and HL7 FHIR, and many more, underpinning the information flows between actors and systems. Still, there is a data chasm, as expressed in the Tim Berners-Lee essay before mentioned in Scientific American. The professional vocabularies do not communicate outside the domain, and citizens and patients see everyday miscommunication, and things get lost in translation between different communities. Easily expressed in an everyday user journey these days, when we all struggle with COVID-19, trying to find a primary care provider where you can get a test or get a vaccine shot. This should in best of the worlds be encoded with using FHIR resources for health service, maybe some directory services for services, and be exposed in using the schema.org different metadata representations in the best of worlds. So we get all these critical signals about opening hours, provisioning of service, location, instructions to us citizens and patients in a decent and well documented guide to maybe self service provisioning and a participatory design where we as citizens and patients can work in tandem with the professions. Users, as myself, we use Google. But since the information flows do not comply in a full circle, there are several missing pieces in this knowledge graph. Similarly, if we look at metrics, statistics, and feedback mechanisms to all the involved actors to guide their policies, directives, or measures to best cope with the pathogen and level learning culture in the whole value ecology, to capture collections of data points and means to build analytic models, they fail to measure up because it's difficult to trust the data. Hence, enacted fair data principles could become a remedy. On the bright side of the road, we have seen outstanding results in innovation and global collaboration to provision treatments and as vaccine in a never seen manner before, where pharma and societies work together. In this space, the underpinning of FAIR have shed light on the data collaboration within the whole ecosystem. We're also seeing what's called in popular terms as digital twins appear, where things create a dark digital shadow of matter as the notions of IoT. These emerging technologies with ubiquitous computing, edge computing, create an ambient findability challenge. The notion smart cities or smart buildings imply that the digital twin have a sustainable set of models that will organize the data streams into useful systems of signals. In this, the city or the information model or the building information model should need to interplay. The codified knowledge in technical standards, specifications, regulatory constraints, requirements, 3D models need to cope with the data lifecycle. There are building blocks in this as the building topology ontology launched by W3C, Bricks, Sanref, Real Estate Core, or Open Services for Lifecycle Collaboration. And they act as candidate vocabularies to create a knowledge graph where physical things interplay with moving objects as models for autonomous vehicles or humans, we people who live and populate these physical infrastructures, interacting and using our personal systems, wearable computing and services, and that the whole thing here between things and smart things and us needs to become kind of a digital ecology, if you will. From a professional viewpoint, as in engineering, construction, and more, this taxes new way to work together to manage trusted and sustainable data assets from A to Z. Another view to this speaks about security and balancing privacy for the individual actors, so these smart infrastructures do not realize a dystopian future, panopticon. And lastly, speaking about the environment, our shared resources in nature as oceans do have great opportunities to level the use of AI, graphs, and digital twins means to create a value ecology where we reach for a sustainable future. The blue economy and digitalization will bring us more effective means to safeguard and cultivate our oceans. So the final thoughts I have around this is that, well, it all is people centric. It all boils down to people. We, the people, having the human in the loop to network all modalities of life, tools and access point to data, as well as breaking the silos between different actors, professions, and organizations in the value ecosystem. By all that, I hope to shift gear now and leave the word to my talent, Jim. So please, Jim, the show is yours.
Okay, thank you, Frederick. I will turn my camera on. I will share my screen. Okay, I should be sharing Frederick's slide, right?
You are.
Excellent. So thanks, Frederick. That was great. I've always really appreciated and admired your breadth of understanding of the technical landscape and be able to express it so eloquently. Just one bit of background. I'm a solution architect and information scientist at Smartlogic, and our product Summerfor helps you get the most value out of your data by applying what we call semantic AI, and I'm going to get into that a bit later. But what I want to talk about today for the rest of our time is how FAIR fits into other contexts. Based on our experience at Smartlogic, based on my experience working with a lot of different clients, and I hope it'll give you some ideas on how to make your own FAIR data journey successful. So I wanted to look at FAIR in the context of information architecture, because that kind of relates back to where Frederic and I all got started in our collaborative friendship, and then in the context of librarianship and some other context with other Smartlogic clients. As I said, how are other organizations doing this for these FAIR principles that are really taking off in a lot of research organizations primarily. And lastly, we'll look at FAIR in the context of knowledge graphs and semantic AI. So information architecture and the context of where Frederic and I got started together back in our, like he said, 18 years ago. I really hadn't thought about that, but it was that long ago, and it was the age of corporate portals and intranets being developed, and we were a new company merging across several continents, and we were both involved in the projects to organize enterprise information for the distribution of information effectively to users downstream. And kind of both of our Bibles at the time, if you will, was the information architecture for the World Wide Web. So this is specifically in the context of websites back in, back at the turn of the century, really, when the first edition came out by Rosenfeld and Morville. And it is still a reference that I go back to when thinking about how to successfully implement information solutions. And FAIR data principles are no different. And the real value of it, it always comes back to this Venn diagram, which is some people can't stand, some people think is great. I think it's great because it really focuses on these three elements. The content is important. The FAIR data principles are very much about the content. How do the digital objects get encoded to meet all the principles? But equally important are the users and the context. Context includes things like culture, other technology, other perspectives. And for any successful rollout of things like the FAIR principles or corporate portals or enterprise taxonomies or any of these things, all three of these have equal merit. So when we were working in the corporate portal, we realized we had this shared view where it was all about making information available to people when they needed it, where they needed it, as opposed to kind of the general tendency, which was to, well, I'm going to build an organization site. All my organizations in my company are going to have sites. And one of the principles from the information architecture textbook is nobody cares about your org chart. It's all about getting people the information they need to make decisions. And how is that different from the FAIR principles, really? The next context is libraries. Now, I know you're thinking, oh no, he's going to start talking about the card catalog. Well, not really, but I do want to stress the importance of the context of libraries, because when we talk about the principles of information sharing and encoding data very carefully and very specifically to serve certain purposes, I kind of suggest that librarians probably invented the concept, and they're still going strong with these concepts. I just want to explain a couple of them. librarians have been writing principles and data standards for a very long time and continue to refine them and keep them relevant. You may have heard of the MARC data standard, the MA, that stands for machine readable. So back in the 60s, we were still talking about encoding data to be machine readable, which is a fundamental principle of the FAIR data. But beyond that, it's just not just encoding the data, it's encoding it so that it's accurate, so that it's correct, that it represents things appropriately. And that's what kind of the second part, the cataloging rules, was all about. And today, these standards are up to date and intended to integrate with the web. They integrate with other web data standards like RDF and schema.org, etc. And again, there's a specific encoding method and there's a specific rules for how you accurately describe things. Resource description and access is kind of the new new word for cataloging rules. And so what does that mean? It means creating metadata for objects, whether they're books, digital objects, databases, whatever. So I wanted to just one slide to look at the RDA in the context of FAIR, because if we just look at these principles, what really jumped out at me is, again, the way the principles are stated is in context of the user. So it's not the data that needs to do something, it's the user that needs to find, identify, select, obtain, and my favorite, understand what they're looking at. And of course, these break down into all kinds of detail, which you can easily find by looking on the web. But I just was struck by how similar they are to the FAIR principles. My last library notion is a little more fun. It's this person, Ranganathan, if you've ever heard of him, he is considered to be the father of library science, whatever exactly that means. But back in the 30s, he came up with these 5 laws of library science, and he wrote books about these laws. And lots of people have written lots of expansions on what these all mean. And I think they're just a lot of fun and easy to think about, and they make you think. They're like cones or something, where what does this mean? And the more you think about it, the more sense it makes. And I think they translate very well to the digital world and the notion of data science, as opposed to just library science. So I had some fun. I changed this a bit and say, well, what would be the 5 FAIR laws of data science, the FAIR laws? Data is for researchers. Every researcher, their data. Every data object is researcher or agent, digital agent or computerized agent for the researcher. Save the time of the researcher. And the best thing is that the world of research data is a growing organism. Now, before those original laws were encoded, the library was a place to get books, and there was certain methods for organizing books effectively. But this really changed things. This to really focus on it's open-ended, and it speaks to the entire future of managing information. So, being a librarian, I get excited about these kinds of things. But I think it's within these rules are a theme that I think is important. And so, why do I think it's important? Well, it's because, if you already have people with a library or information science or any related discipline, if you have anybody with those backgrounds helping you manage your data assets and setting up internal practices and supporting services for those practices, then I suggest that chances are you're already well on your way to being fair, to supporting the FAIR principles. And I see evidence of that with our clients in different organizations and how they operate. And if you're just starting on your FAIR journey, I thought that maybe some of these ideas would be useful. And if you have people with library orientations, you might want to capitalize on that. it's in their DNA to care about this kind of thing. So moving on from libraries, if I just threw this in kind of as a transition to the semantic web, just to put it in here again, you know, when we talk about linked open data, it's not really fair, and the FAIR principles make that very clear, because fair does not necessarily mean open. Again, it's a principle that libraries are very useful for the concept of fair use in copyright. You know, not everybody can read everything. You know, there are rules, there are intellectual property rights that are very important. So there's nothing strange about this to that discipline. I'd suggest that linked open data plus some library information science sensibilities does equal fair data, but linked open data does not. Linked open data is based on the same vision as the web itself, from Tim Berners-Lee, and the web is essentially linked open pages, right? That's how it started, just write pages and link to other pages. And well, we know that doesn't necessarily lead to knowledge or wisdom. It can, but not necessarily. So neither does linked open data, but you know, it's still a place to start, but you need more than that. So building on that, my next context is dealing with, in the context of some of our clients. And some of our clients, the ones that I'm most familiar with are in research organizations, many in life sciences or healthcare. And Summerfor is used for a lot of purposes, for getting the right content to the right customer in a public site, indexing documents for enterprise search, market intelligence, staying abreast of regulations, competitive intelligence, indexing of content management systems like SharePoint, literature surveillance, extracting facts from documents so that they support some analytics or a quality framework in one case, and dealing with records management and being to tell whose information is who when you're working in the area of mergers and acquisitions, et cetera. Some of these initiatives can be related to FAIR, maybe some, maybe not so much. But I wanted to mention a couple anecdotes or examples that made an impact on me regarding how FAIR can be successfully adopted. I have up here on the slide the concept of GXP, good practices in the area of good clinical practices, good manufacturing, good documentation, good laboratory, and these are all things that are very important within the development of pharmaceuticals for the purpose of getting them approved. So they're highly regulated processes within an organization. And as a result of that, managing the data that goes into these submissions is kind of, you know, abides by rules that are essentially non-negotiable. And so this information is managed very carefully within that purpose. The purpose is to get products to market, get them into the hands of patients as effectively and as safely as possible, right? But at the same time, there's a lot of data being generated, and it's not stored or accessed in a way that can be reused as effectively as maybe it could. So there's one example where a company was putting together a new records management practice or policy, and on the one side of the house, you know, the people wanting to reuse the data were very much about the FAIR. It needs to be fair. You know, the records management program needs to be fair. They need to abide by the FAIR principles. Whereas the people more on the GXP side of the house are saying, no, wait a minute, that, you know, we have nothing can get in the way of us getting products to market. And so there's some debate about that. And you know, the message is that both are important. And it's interesting to think about in terms of primary and secondary uses of data. The primary use of the data is to get the submission, to get the product to market, to get patients the medicines, the therapies they need. The secondary purpose is for future research. And one of the data integrity guidelines that I thought again, reminded me of the FAIR principles are these ALCOA data integrity guidelines. And if you read these, which we won't read them in detail, but you can see how much they correspond, they overlap so much with the FAIR principles. But they go a little further, I think, in terms of the quality and accuracy aspects of the data. So, because the management of the data is so driven by the regulated purposes, the concern for its ability to be reused or combined with other data is not the main point. So what made this proposal successful is addressing both and saying we need both of this in how we manage our information in our organization. So it comes down to that FAIR is complementary to other standards. As Frederick said, there's and the FAIR principles themselves explicitly state there are many standards already out there. There are many of which are domain specific, but that overlap a lot with FAIR. And you have to see them as complementary. They don't replace anything. Oh, we're done with ALCOA, now we need FAIR. That's not how you'll ever be successful. Some other examples from our clients. In my brief survey of some of our customers regarding FAIR and where they are in the organization, that first of all, it's cultural, and as soon as I hear that word, I think of the 3 circles of information architecture. You need to build a culture that is interested in that recognizes the value of FAIR and makes it sharing data that they produce desirable and something that they get rewarded for. And some organizations it was very explicit that FAIR was in their strategic plan. Like we will be FAIR by 20 something. In other places, the team itself was renamed to be the FAIR team, which I thought was pretty cool. One thing that's really different about FAIR, that's different from any library standard or other standard that I could see, is how well it's communicated, how well it's put together, how the focus on simplicity. So capitalize on that. And but then one of the key parts is making sure that it's easy to be FAIR. This is where it gets into the tools and things like Summerfor, where the whole idea is to make it easy for people to be able to choose the values they need, or to have assisted classification. And when people have to tag their data, don't put too much emphasis on some very complicated data structure or ontological structure. Make it simple, so when people are at the point of tagging data, they can do it simply or automatically. With the right AI tools or semantic AI tools. And finally, make sure that it's supported with processes. Putting together a FAIR flyer and hanging it on the wall, or making it even a strategic direction is I would suggest is not enough. You need to support the process with service when people have questions, when people can't use the tools that you expect. Make sure they have the backup to help them. So I hope that's helpful in the context of where you might be in your own journey. Let's switch to FAIR and knowledge graphs. So the last part of our discussion. I think it's fair. It's fair to say that the FAIR principles are really about knowledge graphs. It's all about connecting data together, making it all the interop. I'm looking at the standards here. That's why I keep looking over there. It's the interoperable, reusable nature of it that depends on the proper identifiers, etc., are basically the point to create a graph. Because when you think about it, knowledge graphs sounds like a technology, but knowledge already is a graph. How we think about information is already graph-like, and how we make connections and form hypotheses and judgments, etc. But as a computing concept, it's about, well, how do we encode data in a crude, in a simple way, so the computers, which aren't yet as smart as we are, computers can make decisions much faster. So the FAIR principles enable the graph, and so that humans, and especially machines, can traverse the graph, which requires all those principles. So before I talk about how, get into the Summerfor and some pictures of knowledge graphs in Summerfor and how we enable that, I'll quickly just say what Summerfor is. Notice we haven't done that yet, and this is a Smartlogic co-sponsored webinar. So I want to mention Summerfor is we call it a semantic AI tool, because we use both semantics and AI in how we enable its capabilities. And one is to build semantic models. And the whole primary mission and design principles of Summerfor is that it's easy for subject matter experts to use. It doesn't require advanced ontology degrees or anything like that to understand how Summerfor works and to interact with it and to make contributions to it. So that's what the semantic modeling part is about, as well as making use of those models to do really sophisticated text analytics or any type of textual data analytics, looking at a document, looking at a piece of data, harmonizing it, standardizing it, normalizing it for different values, etc., as well as doing things like extracting data from documents, which is a really powerful feature I'll talk about a bit later. And lastly, to make those models easily consumable. I said before, if you're going to try to get people to tag their research objects as they create them, make it easy. Provide tools that integrate directly with your with workflows in the tool they're already using. So the knowledge graphs, how are they built? The place where they might most often start is your databases. Let's get all our databases and put them into the graph. And this may be reflected what this was like with the data lakes of yesteryear, where people put all their data in the lake and it still didn't make any sense. So the next step might be, well, let's get ontologies into the mix, and ontologies can help draw the relationships between terms that are used differently in the databases, and they can make connections that aren't explicit in the data. And that's a really important part of it. So that can start to form the graph. Where Summerfor adds a little bit, and when you think that a lot of your data is still in documents. So how do we leverage that data? Some of the official versions of information about products are in official documents, regulated documents. So Summerfor adds that component to it as well. So being able to look at, basically model how you want data extracted from documents. And so that can go into the graph as well. So sometimes that information in the document might be the missing link that makes your graph yield some new piece of information. This is that graph in a little more detail. I want to show you this quickly in Summerfor in the last couple of minutes here. But you can see I've got data regarding ontologies. I've got data regarding documents. And if we looked at that in Summerfor itself, let me bring Summerfor over here. So this is one of the tools that comes with Summerfor, and it's an easy way to browse the Summerfor graphs. And in this particular graph, which is the same graph that represented that picture before, I have a number of different data points. So we're in the land of pharmaceuticals here. So let's look for a particular drug that might be of interest. And this is just a random assemblage of drugs. There's no particular product or organization represented here. We can see as I start looking in the graph, I'm immediately assisted. Do I mean a document about Tarceva? Do I mean Tarceva the drug? I can quickly go in and start browsing around and seeing what I know about Tarceva. I can see it's part of a particular therapeutic area, and I see that some of the facts are actually coming from a document. So if we look at that document, we can see this document we've extracted certain facts from this document. For example, we've extracted saying that this document, which is about Tarceva, has these adverse events, adverse reactions identified. And this is important because, you know, the word fatigue in a medical document could mean a number of things. It could be the indication for a product. It could be the adverse reaction. It could be the contraindicated condition. But here we've extracted explicitly because it's the adverse reaction. So now we know that this document indicates that Tarceva has this adverse reaction. But if we go to the fatigue, we can see, well, actually, we're using a public ontology, a particular, not really public, a standard ontology of clinical findings. And for that, I can go up broader up into that ontology. So I can say, well, show me all the drugs that have adverse reactions under the general topic of aesthetic conditions, for example. But from fatigue, I can see the other documents that might be relevant to this. For example, if I go to Isodex, I want to show you a couple of things that are being extracted here, not just the adverse reactions, the stated indication, what drug the document is about, but also look what we're taking out of the document on the right-hand side here. Things like the fatal warning sentence. Were any of the studies cited in this document related to a particular type of clinical study? And you know, the pregnancy risk summary, things that we can extract from the document like the serious warning, etc., as well as all the relationships that might be relevant from that document. So at this point, you know, the document has now been turned into data, and that data can be added to your graph along with your databases, along with your ontologies, and that's really how a graph works. And how does a graph work? Well, because graphs have to basically follow the FAIR principles. They have to use standard identifiers. Everything in this model is using standard identifiers, and the data extracted, the documents, they all have been assigned identifiers to make them traceable that way and connectable and reusable. And here I'm just looking within Summerfor. This data could be put into a larger graph, obviously, instead of just using it within Summerfor, for example. So lastly, if we go to the next slide. This is really my last slide, talking about knowledge graphs in a wider context. And it relates, I think, back to, you know, where are you on your FAIR journey? Where are you on your metadata journey? How is your organization managing metadata effectively? And if we look at the wider context, the idea of a semantic AI tool like Summerfor, and I should mention the AI component of Summerfor is really about the whole natural language processing capabilities built into Summerfor, combined with the ontology capabilities, is really what allows us to do that sophisticated type of text analysis and extraction by understanding language and applying it with ontologies. But the metadata journey that you might be on, you might be back to just trying to, well, can I at least manage all my products in one place, or information about my products? Am I enabling search with well-managed taxonomies? Am I extracting data? Am I building a metadata hub? All the way to, on the far right, are we actually building an enterprise knowledge graph where we can actually use all this data that we're building using FAIR principles and tools like Summerfor to glean new information? And that's where we like to have the conversation with clients about where they are and how Summerfor can fit into whatever stage of the journey they're in. So with that, I think I'll conclude and go back to the Q&A.
Thank you, Jim and Frederick. Great presentations. We have a couple questions. And the individual who asked the first question is no longer here, so if we need clarification, we may just have to skip over it. But the question is, what about knowledge graphs and blockchain? I think, Frederick, you briefly made some mention of blockchain, and maybe the individual is looking for the connectedness or how they interact.
Yeah, definitely defer to Frederick on that one.
Well, the blockchain technology, well, it's a distributed ledger and end of state where you have encryption so that you can be as secure with no central agency being responsible for the keeping the ledger intact. But that said, meaning that obviously there is linkages between the different entries in the ledger as if you take currencies where we are using this blockchain technology there's a set amount of possible coins, if you will, bitcoins, and then you have a kind of a market where you take out and in and out in a kind of a transactional model, in a keeping track of the ledger of the value of that asset. That is a kind of a linked model in that sense. But if you take, for instance, very fascinating, I would say, fascinating new emerging uses of the blockchain technology with the non-fungible tokens. And recently, I think in February, the most expensive, or next to the most expensive, sold art, was a digital art item sold for almost 60 million US dollar. And the whole concept here is that when you think about something that's non-fungible, because I mean that's kind of a difference between a token and a ledger. When you have something like a currency and you have it's transaction based in that sense, whereas here non-fungible states that there is just one piece of Mona Lisa and it's hanging in Paris, the one, but then there's multitude of copies, posters of Mona Lisa, but the one who owns the one and only Mona Lisa, he's a fortunate guy. And this is the same thing here, that you use kind of a coinage and put a minting stamp on any digital object, and you can use that with the non-fungible tokens, which is also based on the same kind of blockchain technology. And I think recently, during the spring, one of the editorial pieces from New York Times, one of the guys wrote a piece to describe how the concept of non-fungible tokens work, and then he minted that specific article, which is publicly available on the New York Times site, and said, well, here's my item. I have now an NFT stamp on this one. Say, if you want to get hold of the one and only NFT version of that one, and he put it out to the market for $150 US, because there's a market for these NFTs. And I think within 2 days, it ended up in 560,000 US for this, token or this, this thing. And when I read his, following paper, and they said, well, now it's up to 725 US. We said, I mean, this is the most valuable item I own. It's even more expensive than my house, if you will. So yes, I mean, the technology behind blockchains they are not a knowledge graph in that sense. It's not RDF based, but it's I could also, speak about some of the, emerging the standards coming out from W3C and Tim Berners-Lee, speaking about privacy, which is, kind of where you have your private pod of your data which you own, which also, is kind of similar, thinking as kind of a blockchain where you own your pod of your data, and then you have using semantic technologies to describe this one. Sorry about the long answer. Fun story, fun question.
Okay, we have a few other questions, and I think this is a good one. Maybe both of you can weigh in on it. Do you have any predictable suggestions on where to start in becoming fair? And Jim, I'm going to open that up to you, and I'd probably let you both speak to that because it is a thing that you both like.
Yeah, I'll go back to one of my slides where I talked about how I saw other organizations being successful. It's really it's a cultural change. So you need to start talking to people about it. Meet them where they are. They might already have standards, and you come with them with yet another set of principles, and they'll say, well, why do I need this? So it takes a kind of an empathy, if you will, with other perspectives, and of course, management support helps so that somebody says, yes, we are supporting the FAIR principles. So when the person comes and talks to you about them, listen. And the other kind of side of that, that one client specifically stressed was providing the infrastructure for being fair. So if you're starting with one piece, like tag your assets, make that as easy as possible. Provide the support services so that people know what to do. So in terms of getting started, I would think of those two angles, two approaches.
And I would just copy what Jim said and say, well, my experience in this is that, well, people or organizations accidentally become fair. They have a stated possible thinking about an outcome. We need to pull together some resources to solve this specific issue of having a well-concerted, orchestrated vocabulary that speaks the language that we have internally. And the second one would be we need some kind of data catalog to keep track of our data assets. And if we, by incident, just follow the FAIR principles, well, these things just jack into each other, and it actually becomes fair. But I think as you mentioned here, Jim, also that it's a very good acronym because it's very easy to say. I mean, who wouldn't like to be fair? I mean, to be non-fair is is not so good, and that I think that is also why it has got some good traction outside the kind of the scholarly starting point where researchers wanted to be able to get hold of data assets collected for one single first purpose use, and then say, well, can I build on top of your models or your clinical studies, and is your data points possible to make another level of meta discussions about this one, which was the starting point. But then again, I think it's all about culture. Well, the technology, I mean, make it simple. I mean, it's
right. You can't just change the culture and then provide people no tools to do it. The culture won't take.
No.
If it's hard to it's hard to comply, right?
And anybody who's been working with large enterprise systems based on SQL, traditional relationship data models, you've seen those diagrams with 350 reference tables and links and so forth, which is it's you can see the forest because of the trees, because in that so the simplicity of expressing your domain into a graph, that is why it's so compelling. I mean, it's like things to a large extent, most of the things are actually represented in nodes and edges. And if you can do that, translation simply with the discussions with the subject matter experts, and like, okay, you have, as you were just navigating your graph when you just showed the rule, well, these are the dimensions to the things I would like to look at. And then it's opening up some new venues that I didn't think about, because I mean, that was part of what is in the document. That is kind of why I think it start to make sense. But a very good question.
Yes, and unfortunately, we are at the top of the hour and out of time. I want to thank you both, Frederic and Jim, for speaking with us today, and to all of you that attended. I want to thank you for your coming and sharing your time with us, and I hope you found our webinar valuable. And with that, I'm going to say have a great day.